graph nodes, Lavin and me today going to explain different several platforms are available in big data analytics. So the primary purpose of this paper is basically give you very deep information about different platforms are available in big data analytics in terms of hardware and software, and give you very deep information about how you choose a correct platform to analyze this data. So these are the content of this paper we are going to do. Scaling the ability of the system to increase the data processing, and broadly there are two types of. First one is horizontal scaling and second one is vertical scaling. For horizontal scaling, there are millions of computers which are connected in a single network. That means in the horizontal scaling, the millions of computers are connected with each other and they are working parallel to each other. That means if we give a task to them, they will divide that data into different parts, and each computer will work differently according to the data. And for the vertical, there is only one system is there, but the system's processing type is very high and very huge amount of capacity to the in terms of processor, memory, and hardware also. So horizontal scaling, some platform include in horizontal scaling is peer-to-peer network, Apache Hadoop. And first one, peer-to-peer network. Peer-to-peer network is involve millions of computers. They are working together. So in peer-to-peer network, each nodes can send the data and then can also receive the data. And the peer-to-peer network also works as master and slave systems. The slave nodes can work only the master computer will give some command and give some orders for them. And for the broadcasting, peer-to-peer network is very cheap because they can only send to one server, and when they are collecting the data are much expensive. And the slave machine can also be a master machine because once they receive the data, they can send to others also. So drawback of peer-to-peer network is basically fault tolerance. The fault tolerance is like they don't have the ability to rebuild the disconnect between the computers. If the two computers are disconnected, then they don't have that ability to reconnect by themselves. Later on, Lavin will talk deeply on that. And Apache Hadoop. Second is Apache Hadoop. Apache Hadoop is open source framework which is used to store data and processing this data. And Apache Hadoop was developed by Google in 2003 by Kadin and Mike. And Apache have two important components. Hadoop distributed file system and Yarn is basically used to store the data. How they store data? Once the master nodes receive some kind of data and they divided that data and give to the nodes, different nodes, nodes data, and each node's data we store each amount of data on there. And also Hadoop distributed file system is very fault tolerance. If the data is not fault to store in the nodes, then the master nodes will receive a message and the master nodes will also give Hadoop Yarn. Hadoop Yarn is yet another resource management. That is basically for resource management. And Hadoop Yarn is not there in Hadoop 1.2.0. It only comes in Hadoop 2.2. How they are managing? They are managing in terms of schedule and task management also. So we program model of these hard-to-base MapReduce. MapReduce is basically they are doing two works, kind of mapping and reduce. They once they receive the message or the data, they divide it into different. And the limitations of MapReduce is insufficient of additive algorithms, real-time processing, and graphic processing, and memory processing. That's and the Spark next generation data analysis. Spark is very important in Hadoop because Spark is much more good than Hadoop. In terms of Spark is open source cluster computing framework, and real-time processing also can be there. And irritation unique features that much faster. Spark is much faster than Hadoop. Around 100,000.
So there are various platforms available in commercial scale. First one is HPC, that is high performance computing cluster. Then and multi-core CPU. Then we have GPU, that is graphic processing unit. Then field programmable print array. So we will talk about HPC, that is high performance computing cluster. So HPC is all about blades or supercomputer having thousands of ports in that. So they can have different varieties of this organization catching and depending upon the user requirements. So this platform is having a hybrid hardware. So which are optimized for speed and throughput. So the initial cost for deploying that hardware will take huge amount of money because they the initial cost of deploying such system can be very high because of the use of having the hardware, and they are not as scalable as Hadoop or Spark, but they are still capable of processing terabyte of data. So in multi-core CPU is all about one machine having thousands of cores. So they usually share one memory, but they usually share memory but having one disk, and they have number of core per chip, and the number of operations that core can perform has increased. And so the parallelism in CPU is mainly achieved through multi-threading. So the task has been broken down into threads, and each thread is executed in parallel of different CPU code. So most of the programming languages provide library to create threads and use CPU packages such programming language is Java. So the drawback of this multi-core CPU is they are having a limited memory. So once the data size is increased, so they can handle that data because they are having some limited amount of memory. So to cope up from that, we are having graphical processing unit, that is GPU. So GPU is all about, it is a specialized hardware which was designed for acceleration, the creation of image in frame buffer intended for display output. Like it's generally used for like creating image or videos in the early stage, but in the 20th century, developers have come together and they got to know like GPU has more importance, and so actually GPU has more importance because of the parallel processing which GPU can done. GPU can do. So GPU has large processing core, almost 2,500, as compared to multi-core CPU, which is multi-core CPU has only have double digit of processing core, and GPU has its own DDR5 memory, as in compared to the DDR3 memory which multi-core CPU use. And so the main purpose of GPU is parallelism. So parallelism GPU has two levels of parallelism. So at the first level, there are several multi-processor and streaming processor. So within each multiprocessor, there are several streaming processors. To use this setup, GPU is broken down into threads which execute on SP. So GPU is broken down into threads which execute on SP, that is streaming processor, and these threads are put together to form thread block, which will again run on multiprocessor, that is MP. So each thread within a block can communicate with each other, but they cannot communicate with other MP, that is multiprocessor. Means each core can communicate with their belonging core, like in the same multiprocessor, but they can't communicate with other multiprocessor. And any job run is, that's what I talk about that. So the main drawback of GPU is they are having a limited number of memory, like their memory size is very less. So they are having a maximum memory of 12 GB. It's not suitable for terabyte scale of data, like they can't process a terabyte of scale of data. And if once the data size is increased, then GPU can't work as faster as the other platform which we are going to talk about. And another drawback is the limited number of software and the algorithm available for the GPU, because it's earlier the GPU don't have that importance because it is only used for video or image editing, but now the developer has come together and they have found out they haven't developed many number of software and algorithms. So that's the main drawback for GPU. So now we will discuss about how to choose platform for big data analytics. So there are different factors which we have to look on that before choosing any data. So we will see the data size, then the speed or throughput optimization and training or applying a model. So data size, so if you are choosing if you are working on big data analytics, you have to see the data size. So data size, if the data size is very large, then you have to go for peer-to-peer network, because they can only do a horizontal scale up. They can do a scale up to any extent. So for that you can use peer-to-peer network. And if the data does not fit into system memory, then you can use option like Hadoop or Spark, but they are not. They cannot give you the output in real time. For that, if you need a output in a real time, like in a real time processing as we talked earlier, then you have to select FPGA and GPU, which I have mentioned. So that speed or throughput optimization, that's what I was talking about. So speed refers to the ability of a platform to process data in a real time. So and throughput is the amount of data that system is capable of handling and processing. If one need to process large amount of data and does not have any issue with processing time, then we have to choose peer-to-peer network and Hadoop. And if you are looking for the speed, and if you want output in the at the same time, then you have to go for FPGA and GPU. And training and applying models. So when you are in training, so people will not look for the output. They will look for what you are working there. But if you are applying a model, you have to look for the output that will be in real time. So in training, you will have large amount of data. So for that, you will select peer-to-peer network. And if you are applying a model, like if you want a output in a real time, then you can go for HPC cluster, and because HPC cluster can handle more data. That's all for our presentation. Here are the reference which we have taken.